Hey, welcome back! I know it's really hard. Making a source by bringing together on-chain and off-chain data is really challenging. And this is exactly what I will explain you in this video. I will show you how to leverage the chain state history in real time, or a way to catch produced blocks that are validated and broadcasted across the network. So buckle up and take note, because it's gonna be a wild ride. Okay, so you have to understand first that solution is not for basic dApp, but it's almost mandatory when you need to deal with large-scale project use cases. When you have to aggregate a lot of data, deal with complex data structure, keep a part of your data private, or even notify your user about his transaction on your smart contract. So why building such a solution? Because on XPR Network, smart contracts are really resource-wise. You have to be careful about how much data you store in RAM. You can't really push massive string like HTML or JSON. Also, JSON RPC and API are not designed for performances. They have really high response time. They provide a limited set of results, and sometimes you may be forced to query multiple times the same contract to have all your data. Finally, on-chain storage is not database at all. You don't have foreign key-like ability you may find on database query language. You cannot query multiple tables in the same request, and there is a limited type field set for lookup. This solution is 100% Node.js, and it relies on a library made by the guy at Blockmatic, and the name of the library is Eosio Ship Reader. It's built around RxJS observer pattern, and it allows you to catch the block and filter them according to the contract you are listening for. It's run under PM2. PM2 is a daemon runner for Node.js script. It allows you to have a scalable structure and a granular control over your script. And the cherry on the top of the cake is that solution could run on a really small server. Now, ladies and gentlemen, it's time to dive in. So let's hit the code. Welcome to the code. The project has been initted, and for those who want to pull the code as it, there is a code repo in the video description. For those who want to go from scratch, I will provide a breakthrough through the code, and let's go. So you have to be careful of what's inside the package.json. Some dependencies are really fixed to match the configuration between the Node, AB, EOS, RxJS, and the Blockmatic TS config. I will show you the TS config right after. And the per dependencies, you should make it at this. So don't worry about it, just copy paste it and hit npm install or pnpm install or whatever. I use bun, but you can use whatever you want. So the project structure is we have a SRC folder where our ship reader lives. I will talk about it in a few. We have some utils to load env variables and some utils to catch to fetch ABI and different things we have to catch before running the ship reader. And we have an action folder and a tab folder. I will talk about it in a few. About the TS config, you have to be sure that you install and extend the TS config provided by Blockmatic. That's something that I don't like really, but hey, we don't have to create it from scratch, so be happy to just have this to configure. Next we have to discuss about this little bastard is ecosystem.config, and it's a way to tell PM2 what's the name of the script and where he can find the script and where he can load the script. And we provide information about the environment and the environment production. So it's a way to tell him, okay, load that script, name it monitor.rows, and load this the env from development or env from production. And this those env are defined here when we call the start or the start production. And the start with the development env, and the prod start with production environment, but is not defined here. Inside our environment development, we have just two little variable, which is the node ship WebSocket URL and the node ship HTTP URL. Okay, it's the URL from the node, and it could be a block producer or a validator. Okay, it's fetch it's connect with the WebSocket on my own block producer. It's not the block producer, it's just the API. It's connect on the WebSocket on my API on that port, and it's it fetch the ABI. Okay, I will talk about it in a few. It fetch the ABI from this address on my node. You can use this. This is my node. This is my API node. You can use it. It's public. It's a gift for me. It's for you. And those two little variables are used in the ship reader himself. So you have to be careful about these two variables to be sure that they are in your file, and you have to be careful about table row whitelist and action whitelist. Okay, what are they? When you connect to the WebSocket, because the WebSocket broadcasts every blocks produced and validated, you receive every blocks. That means you receive a massive flow on bytes data. Okay, so these are whitelists to say, okay, I don't want any other block except the block that coming from eosio.token, where the code are eosio.token, and that's speak about this table. Okay, and for the action, it's pretty the same structure, except that you have to mention the action, and we want the transfer action. Okay, so on the token that's handle transfer and issuance about XPR, we want to listen the transfer, and for the token that's handle transfer and issuance of XPR, we want to listen for mutation on the table's account. By mutation, I mean creation of a new row, removing a row, or mutating a row, or changing a row. Okay, so this is where you have to define what contract you are listening on and what table or action you are listening for. If I want to listen a table from my bed XPR contract, bed XPR, and I want to listen for predictions. Okay, this is how I say prediction. Okay, this is how I define it. It's quite simple. Okay, so I will remove it. And you have to be careful that the configuration load the right variable for the WebSocket URL and the RPC URL, and it's really important. And that's why I have some console log. So when I start my project, I can see, okay, everything's run on this environment and the socket is listed on this URL, and we fetch the ABI on this URL. Okay. So what are ABI? ABI are blueprint from a smart contract that tells the chain and other system how to deal with the byte received when the block is coming. So a block is just a bunch of bytes, okay? And the ABI is the blueprint that explain how services on chain or even our Azure ship reader, how to decode this byte, how to deserialize it, and how to make it plain old JSON object. It's you can find ABI on a smart contract, and you can check here in the table in the tabs ABI. It's not really fun to read, but sometimes you may find useful information about how the smart contract work, what it accepts as field, how field are structured, what the type, and so on and so on. And to be more informative about this, the action tab use ABI to generate those fields with the right data type. Okay, so let's back to our ship reader configuration. So this file just expose the the load reader function, and the load reader is what you use in your script to say, okay, I would like to have a connection with the WebSocket, and I would like to receive all block about one of this contract I'm listening for. And that's why in my SRC folder I have an action folder and a table folder. Okay, the action folder is used to listen actions, and the table folder is used to listen table. Yeah, I'm a genius. Here I have my little script, and it's really little because we hide all the process inside this ship reader. And we import the load reader function from ship reader. This file we see in just a few. And I have the run process function, which is an async function to allow me to use the await operator, and this run process is invoked right after the script is loaded. So the run process load the reader by our load reader function, and it return RxJS object. I invite you to check at the RxJS. It's something quite complex, but once you understand it, it's an observer pattern, and it's something that's really powerful, but sometimes getting started with it could be a mess. We doesn't have to deal with it here, except by getting those destructured objects from the load reader. Okay, the start method is just a way to say, okay, let's start the ship reader for this script. The close is receiving an event when you lose the connection or the connection are closed from the WebSocket, and the rows are the flow of the block that are filtered by your whitelist configuration, action whitelist configuration, and table whitelist configuration, and you subscribe for it. So that means you listen it carefully to catch everything that's happened. Okay, and here I've just so when you receive a block, it's deserialized first inside the process of the ship reader, and the row that's here as a function params is our JSON deserialized. So it comes the bytes, it deserializes it inside the ship reader, and it throws us some JSON at the end. So here I have a console log that say, okay, we have rows, let's see what inside. Now let's back to our ecosystem.config.js. It's a way to tell PM2 how to load script, where to load script, and how to name it. Okay, so I have my little script named monitor.action in my action monitor and load it from the dist. Like this, you don't have to deal with importation and shitty stuff like package resolution and so on. And for the rows and table, please load it from tables monitor.js from the dist file, from the dist folder, and name it monitor.json. So now we have our table listener, we have our table script, and we have our monitor. But we will focus only on table right now. So what I have to do now is to build this little piece of code, and I just run build, and everything is in my package here. So run build, and voila, it's built. It just do nothing, then remove the dist folder and create a fresh one from the script they are here. Next, I will run the PM2 start script, and this will throw few information about what is PM2 is doing. So he start the process, he killed the previous process, and it starts our two process named monitor action and monitor rows. And if we go to our ecosystem, we have monitor action and monitor rows. The order matter, the first to be mentioned here is the first in the list. Okay, and now let's see what behind the curtain, and let's see how the magic happens. So here I have nothing. I have my console log in my monitor in the table folder, and I have my console log, but nothing happened here. Everything happened inside the PM2 log for this. So I will log it with PM2 log, and you can say, okay, I would like to log the ID 1, and then yeah, we have information. Okay, so here, if I clear my console, it's continue to flow over and over and over and over, receiving information about our EOSIO token contract on the table accounts. Okay, and this is what happened. This is all the table mutation. So that means the Alim account have a change on his account, and it's changed the value of its balance. Okay, if we go to the smart contract EOSIO token and check in the table, okay, and check for the scope named Alim, which is the name of the wallet owner, okay, you can see that his balance is 61,1900 XPR, and what we have here is the same value. So at some point he made a change of his balance by receiving or sending XPR, and the balance change in the smart contract table. So there is a mutation, and so we receive the block about this mutation. Here we have the present. Present is set to true. That means this row exists in the blockchain, so it hasn't been removed. When the present is false, that means the row has been removed. Okay, it's quite simple. It's present, it's existing, it's just created or mutated, updated, and if it's false, that means the row has been removed. The value field is the value itself. The primary key is the key of the row on the table, and here this primary key means the numeral representation of this name. And this scope is the name of the wallet. It could be different from smart contract. It's really interesting to discuss about it now. Scope are a way to group data inside a single table. Okay, I use it a lot of my own smart contract to ease the way I'm looking up at my information about something. Let's say on my XPR project, we have prediction that are prediction like on Polymarket or whatever, and all bets on that prediction are grouped by the primary key of the prediction. And it's for me it's really easy to look in my table structure, because if I want to see who bets on that prediction, I just take the primary key of the prediction, I put it in the scope, and I have my list of better in my for this prediction. So I don't enter too much in details. It should be discussed in a next video about more about smart contract. So this is it. We've done it. Yeah. We have now a script that catch information about account on the EOSIO smart contract. And if we want to see what happened for the action, okay, we listen for action transfer. Let's see what are called the transfer action. And for this, I will exit my PM2 listening, but my PM2 log, sorry, not listening. I exit my PM2 log, but if I hit PM2 ls, I can see that my two scripts continue to run. That's what means a daemon. A daemon is something that runs inside your computer in a separated thread. Okay? So now I will run PM2 log, and I log the ID 0 to have information about the action. Okay, look at the structure here from our rows. Okay, for listening table, and listening action is a little bit different. Okay, so here I receive only the data from our transfer, and for those who are familiar with the transfer action at the smart contract level, we have a from, we have a to, we have a quantity, and we have a memo. Okay, if I go to my action here in the smart contract, if I look at the transfer action, I have a from, I have a to, I have a quantity, I have a memo. Okay, so this is what I receive when someone trigger this action. Okay, and to be more precise about what happened, I will remove the data, because the data from the transfer and from any action contain the field that the action need to be triggered properly, and I will stop it, and I will rebuild it by running run rebuild. Okay, and it's built, and I will run PM2 start, and I restart completely my two script. Let's go back in our log, and now you see I will have a little bit different information about transfer. It may be cool to send them as transfer to worker 1, and I send 10 XPR, and I send with a memo, hello devs, and let's say some emoji. Okay, and you will see it's quite fun because you can use emoji in the transfer. So I clear it, and right now I sign my transaction, and my transaction is signed, and we have hello dev with my little emoji, which is quite cool. So here we have the account name, we have the name of the action, we have the authorization, and we have the data we send through the transfer action. So now you can listen all day long for what's happened on chain and make it whatever you want with it. Okay, and I said whatever you want, it's really whatever you want. You can store it in a SQL table or a Mongo table or any database language you prefer. And you can also do computation, fetch that information from outside your script. You can use fetch something. Okay, you can fetch information from, let's say, what we want to fetch, rate from CoinGecko, and by pulling the rate, you compute the amount of XPR sent here in snips or any token you want, or you can multiply it by the size of the earth or whatever you want. And when I say whatever you want, your creativity is what you limit. It's the only limit you have. Personally, I like to use Supabase, which is really nice Postgres online and cloud services for Postgres database. It's really, really, really powerful, and I love to use it to store my information about what's happened on BedXPR smart contract. In this way, I can leverage the power of SSR, server-side rendering, on React, and it makes your user experience way much faster when it comes to load the home page or a single page on your website. You doesn't have to query information from the smart contract, because as I said in the introduction, JSON RPC and Chain API are not really designed for performance, but SQL or any other database language are made for performances. So you can store all your data coming from the chain, and once you have it in a SQL database, it's really easy to query it, and it's really easy to aggregate it. Let's say I want to know what Dave made this last days and provide statistics. So I have the account of Dave, and I have all his call to the transfer from in or out according is from or to in the transfer action. And with SQL I can aggregate that large set of data in a snap. And if you want to do that with the RPC and pure on-chain data, you can do it. If you want to piss off your user about response time, it's your call. But I really, really, really like this way to work with data on XPR Network. So that's it for this video about how to leverage chain state history in real time. I hope you enjoy it. See you next time.